Now in this video, I'm going to show you how to very quickly plan the scales for your graph. So these are the values for your x-axis and these are the data for your y-axis. Now look at the data for your x-axis. The smallest value is 5.2, largest is 15.2. So you're going to take 15.2 minus 5.2, divide by 12. Why divide by 12? Because along your x-axis, there are 12 big squares. So use your calculator, do this calculation, and you see this number 0.833. What's the meaning of this number 0.833? It means that if you start from the left 5.2 and if you increase by 0.833 every big square, then at the other end will be 15.2, which means you have totally spread out your data across the entire graph. But of course, you cannot increase by 0.833. That's an awful scale. So instead of increasing by 0.833, we should increase by 1.0. That will give us an acceptable scale. So this is how your x-axis look like. So we start from 5. Of course, you don't want to start with an ugly number like 5.2, right? You start with 5, increase by 1 every big square, and 15.2 will sit somewhere here. So that's a good spread of your data along the x-axis. Now let's look at the y-axis. The data ranges from 0.275 to 1.08. So take 1.08 minus 0.275, divide by 8. Why divide by 8? Because along the y-axis, you have 1, 2, 3, 4, 5, 6, 7, 8 big squares. So use your calculator and you're looking at this number, 0.100625. It means that if we start the graph right at the bottom with 0.275, and if we increase by 0.100625 every big square, then right at the top of the graph will be 1.08. But of course, we cannot increase by 0.100625. That's a terrible scale. So should we increase by 0.1 instead? No, cannot. Because if you increase by 0.1, you run out of space. So you cannot go smaller. You can only go bigger. So instead of increasing by 0.100625, we should increase by 0.2. So your y-axis looks like this. You start from 0.2. You don't want to start with an ugly number like 0.275, yeah? So you start from 0.2 and you increase by 0.2 for every big square. You end up with 1.2 here. 5.2, 1.08 will sit somewhere here. And the other extreme data, 15.2, 0.275 will sit somewhere here. Which means you have occupied 1, 2, 3, 4, 5 rows out of 8 rows. That's more than half, right? You've got to occupy at least 5 rows. As for columns wise, it's even more obvious, yeah? You have occupied 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 columns out of 12 columns. So that satisfies the requirement that you occupy at least 7 columns. Okay, let's try another one. So your X data ranges from 2.1 to 36.5. So take the difference divided by 12, you get 2.87. So if you increase by 2.87, the data will just fit the entire graph. But we don't want to increase by 2.87, so we should increase by, well, you have a choice. You can increase by 4 or you can increase by 5. Because both 1:4 and 1:5 are acceptable scales. I'm going to go for the 1:5 scale because the 1:5 scale is easier to read. And going from 2.87 to 5 is not more than double. So I know my data will still be sufficiently spread out. Okay, let's go for the y-axis now. So smallest number is 0.1, largest number is 16.9. So take the difference, divide by 8. I get 2.1. So remember, we cannot go to the next smaller number 2, yeah? Because that will mean that you don't have sufficient space on your graph. So the next bigger number will be, again, either 4 or 5. So this time around, I'm going to go for 1:4. Because if I do 1:5, I'm jumping from 2.1 to 5. That's more than double. If I more than double this thing, I will not be able to spread the data across more than half the page. In fact, you can see here 2.1.1 will be occupying this square, and 36.5, 16.9 will be occupying this square. So I will have occupied this area of the graph paper. For the y-axis, I'm occupying 5 out of 8 squares. That's just sufficient to satisfy the requirement that we occupy more than half the graph paper. Remember, half the graph paper is not enough. It must be more than half the graph paper. So occupying 4 squares on the vertical axis is not enough. Got to occupy at least 5 squares. If you want, you can always center your graph a bit. Maybe it looks a bit more presentable. Now, of course, you could have chosen to plot your graph in portrait mode instead of landscape mode. So sometimes if you try between portrait and landscape, one of them may give you a significantly better spread. But remember, the rule is just to occupy at least half the graph paper. So this scale is good enough. Just a quick reminder, the objective is to spread your data out. Yeah? Whether your graphs includes the origin or not is not our concern. If it happens to include the origin like here, good. But if it doesn't, it doesn't. See our earlier scale just now? Our x-axis did not start from 0. Our y-axis did, but it doesn't have to. We could have started from 0.2 here, 0.4 and so on, because we are only concerned with spreading our data out across the graph paper. Alright, that's all. Ta-ta!